The operating system's 3 easy pieces. The contents, table of contents. Table of contents is 1, dialogue on the book, and introducing the operating system. 2.1 is virtualizing the CPU, virtualizing memory, concurrency, and persistency, and design goals, and some history and summary. 1. Big chapter, but 1. Virtualization. A dialogue on virtualization. 4. Chapter 4, the abstraction, the process, the abstraction process. Section 2, 4.2 is process API, process creation of more detail, and process states and data structures, and summary and references. Homework simulation. 5. Chapter 5, interlude, process API, the fork system core, and the wait system core, the finally the execute system core, why motivated the API, process control end users, and useful tools, and summary, references, homework. 6. Mechanism, limited direct execution, basic technique, limited direct execution, problems restrict operation, problem 2 switching between processes, and worried about concurrency and summary. And 7. Scheduling, introduction, workload assumption, scheduling metric, first in, first out, shortest step first, and shortest time to completion first, STCF, a new metric, response time, and round robin, and incorporating IO, and no more Oracle summary. Chapter 8, scheduling, the multi-level feedback, the queues, and the MLFO basic rules. And attempt 1, how to change priority. Attempt 2, the priority boost. Attempt 3, a better counting. The turning MLFQ and the other issues, and MLFQ and summary. 9. Chapter 9, scheduling proportional share. Section 9.1, concept, basic concept, and ticket, present, annual share, and ticket mechanism, implementation, an example, and how to assign tickets, and why not deterministic, the Linux completely fair scheduler, CFS, and summary, referencing, homework. And Chapter 10, multiprocessor scheduling, advanced. Section 1, background, the multiprocessor architecture. 2, don't forget synchronization. 3, a final issue, cache affinity. 4, the single queue scheduling. 5, multi-queue scheduling. 6, Linux multiprocess scheduler. 7, summary and reference and homework. The Chapter 11, summary dialogue on CPU virtualization. 12, a dialogue on memory virtualization. 13, Chapter 13, the abstraction address space. 6. And section 13.1, early systems, multi-program and time sharing, the address space, goals, summary, reference, and homework. For Chapter 14, interlude memory API, types of memory, memory core, free core, and common errors and underlines, OS support, and other calls, summary and references, homework. As Chapter 15, mechanism, address translation, assumptions, and example and dynamic hardware-based reallocation, hardware support, summary, operating system issues, and summary and references and homework. 16. Segmentation. Chapter 16, segmentation. Section 16.1, segmentation, code generalization, and bounds, and which segment are referencing to. And 16.3 is what about stack, supporting for sharing, fine grain and coarse grained segmentation, OS support and summary, reference and homework. Chapter 17, free space management, assumptions, low-level mechanism, basic strategies, other approaches, summary and references and homework. The Chapter 18, paging introduction, a simple example and overview. Where are stage tables stored? What actually in the page table? Paging, also too slow. As memory trace, summary, reference, and homework. Chapter 19, paging, fast translation, TLBs, TLB basic algorithm. Example, accessing an array. Who handles the TLB misses? TLB contents, what's in there? TLB issue, context switching. Switches, the issue replacement to polish. A real TLB entry and summary and reference and homework. In Chapter 12, paging, smaller tables. Section 2.1, simple solution, bigger pages, hybrid approach, paging and segment, multi-level page tables, inverted page tables, swapping the page tables to disk, summary, reference and homework. Chapter 21, beyond the physical memory mechanism. The swap space, the present bit, page fault. What if memory is full? Page fault control flow. When replacement to really occur. Summary, references, and homework. Chapter 22, beyond the physical memory policies. Cache management, the optimal replacement polish. A simple polish, FIFO, another simple polish, random, using history, LRU, workload example, implementing historical algorithms, approaching LRU, and considering theory pages. The other VM policies, the tracing and summary and reference and homework. Chapter 23, complete virtual memory systems. 23.1, VEX VMS virtual memory. The Linux virtual memory system, summary and references. The summary dialogue on memory virtualization. The big chapter 2 is concurrency. Chapter 25, a dialogue on concurrency. Chapter 26, concurrence and instruction. Section 26.1, why use thread? An example, thread creation. Why it gets worse, shared data. The all of the problem is uncontrolled scheduling, the wish for atomicity. A one more problem waiting for another. Summary, why in OS class. Reference, homework. Summary and reference and homework. 27. Interlude, thread API. Thread creation and completion, locks, condition variables, compiling or running, and summary and references homework. 28. Locks. Locks, the basic idea. The thread locks, building locks, evaluating locks, controlling interrupt. A failed attempt just using load and store, building walk spin locks with test and set, evaluating spin locks, compare and swap, load and link and store conditioner, fetch and add. Too much spinning, watch now, a simple approach, just yield baby, using queues, sleeping instead of spinning, different OS, different support, two-phase blocks, summary references, and homework. Chapter 29 is lock-based concurrent data structures. Section 29 9.1 concurrent counters and linked lists and queues and concurrent hash table. A summary, references, and homework. Chapter 30, Condition Variables. Section 30.1, Definition and Routines. Producer-consumer bounded buffer problem, covering conditions. Summary, references, and homework. Chapter 31, Semaphores. Semaphores, a definition. Binary semaphores, logs, and semaphore for ordering. The consumer, producer, and consumer bounded buffer problem. Reader-writer logs. The dining philosophers. A thread throttling, and how to implement semaphores, and summary, references, and homework. Chapter 32, Common Concurrency Problem. 32. What types of bugs exist? Non-deadlock bugs, deadlock bugs, and summary, and reference and homework. Chapter 33, Event-based concurrency. The basic idea, an event loop, an important API select order loop using select. Why simpler? No rocks needed. A problem blocking system calls. A solution, asynchronous IO. 33.7, another problem, state management. 33.8, what is the still difficult would event? 33.9, summary and references and homework. Summary, dialogue on concurrency. Big Chapter 3, persistence. In Chapter 35 is dialogue on persistence. Chapter 36 in I/O devices is system architecture, canonical device, and canonical protocol, and lowering a CPU overhead with interrupt, more efficient data movement with DMA, method of device interaction, fitting into DOS, the device driver, case study, a simple idle disk server, driver, and historical notes, summary and references. Chapter 37, How to Disk Drive, the interface, basic geometrics, basic disk drive, I/O time, doing the math, and disk scheduling, summary and reference and homework. Chapter 38, Redundant arrays of inexpensive disk, rates, the 38.1, interface and RAID internals, 38.2, default model, how to evaluate RAID, RAID level 0, striping, 1, mirroring, 4, saving space with parity, 5, rotating parity, and the RAID comparison, a summary. 9, other interest RAID issues, summary, references, and homework. 39, interlude, files and directories. The files and directories, the single system interface, creating files, reading and writing files, reading and writing but not sequentially, shared file entry, shared file table entry, fork and up, and writing immediately with fsync, as renaming files, getting information about files, removing files, making directory, reading directories, and deleting directories. Hard links, symbol links, permission bits, and access control list, as making and mounting a file system, summary and references and homework. Chapter 4, File System Implementation, the way to think, our organization, file organization, the inode, directory organization, free space management, access paths, reading and writing, caching and buffering, and summary, reference, and homework. And look at chapter 4.1, locality and fastest file system. The problem, poor performance. FFS, disk awareness is the solution. The organization structure, the cylinder group, policies, how to allocate files and directories, measuring file locality, the large file exception, a few other things about FFS, summary, references, and homework. And chapter 42, crash counts, FSCK and journaling. A detailed example. Solution 1, a file system checker. 2, journaling on the write ahead logging. 3, other approaches. Summary, references, and homework. 43, rogue structures file system. Writing to disk sequentially, writing sequential and effectively, the how much to buffer, problem and finding inodes, solution through the indirection, the node IMAP, and completing the solution, the checkpoint region, reading a file from disk, a recap, what about directories, a new problems, garbage collection, determining block liveness, and purification with blocks to clean, and when, the crash recovery and the log, and summary, references, and homework. Chapter 44, Flash-based SSDs. Storing a single bit, from bit to bank to planes, basic flash operation, basic performance and reliability, from raw flash to flash-based SSDs, FTL organization, a bad approach, a low structures FTL, and garbage collection and mapping table size, and wearing leveling, and SSD performance and cost, summary, references, and homework. Chapter 45, Data Integrity and Protection, Disk Failure Modes, and Handling Latent Sector Errors, Detecting Corruption and Checksum, Using Checksum on New Problems, Misdirected Writes, Lost Problems, Lost Writes, Scrubbing, Head of the Checking Summing, and Summary, reference homework and two homeworks. 46. Chapter 46, Summary Dialogue on Persistence. 47. Dialogue on Distribution. 48. Distributed Systems. Section 48.1, Communication Space on the reliable communication layers, communication abstraction, remote procedure call, RPC, summary, and reference and homework. 49. Sans Network File System, NFS, a basic distributed file system onto NFS, focus, simple and fast server crash recover, key to fast crash recover, statelessness, the NFS version protocol, from protocol to distributed file system, handling server failure with the idempotent operations, improving performance, client-side caching, cache coherence, cache consistent problem, accessing NFS cache consistency, implication on server-side write buffering, summary, references, and homework. 50. The Andrew File System, AFS version 1, problem with version 1, improving the protocol, AFS version 2, and cache coherency. 56. A crash recovery, scale and performance on AFS version 2. 8. AFS other improvements, summary, references, and homework. 51. Summary dialogue on distribution, general index, asides, tips, courses. Okay, thank you. We will read this book, The Operating Systems, and three easy pieces. Thank you for your time. See you next time.